Hello dear aspirants, this is Dr. Sourav Sir's classes. Our contact number is 98367930076. Again, I am repeating our contact number, which is 98367930076. And our email ID is souravsirclasses@gmail.com. So if you have any mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or you can WhatsApp also. Rather, you can drop an email to our email ID, which is written in the screen. So you can enjoy all the services of Dr. Sourav Sir's classes, like you can join our regular batches, our one-on-one sessions and our online classes. So then you can, so then that will be beneficial for your preparation of upcoming examinations like ISI, CMI, TIFR, NBHM, etc. So please feel free to contact if you need any help from us. Okay. So now we are going to solve a mathematical problem which is appeared in the year of 2024, 2025 in the question paper of National Boards of Higher Mathematics, and the question is telling us that what is the number of homomorphisms from the symmetric group S7 to the alternating group A8, that is the subgroup of all even permutations in the symmetric group S8. Okay. So by the first isomorphism theorem, let me, yeah, so that will be easier to see. Okay. So now, where is my cursor? Yeah, so by the first isomorphism theorem, we can say that for groups, the image of any homomorphism from A7 to A8 with kernel, that is our A7 here. Yeah, so that will be A7 must have order 2. Now, every homomorphism of this type will map odd elements of A7 to where? To some fixed element of S7, sorry, a fixed element of order 2 and even elements of S7 even will go to our A8. As such, it remains to count how many elements of order 2 there are in A8. The only such elements possible are products of even amounts of disjoint transpositions. There are two possibilities. Such an element could be the product of two disjoint transpositions or four disjoint transpositions. We know that, so after that we can see that. So if these elements is a product of two disjoint transpositions, then there are 8 into 6, sorry, 8 into 7 into 6 into 5. So that is equal choices for the number of cycles. Because the cycles are disjoint, so recognizing that, let me write, yeah. So recognizing that xy AB equals to AB x y and our xy equals to yx. Sorry, yeah, no, that will be correct. So xy equals to yx. We must have divide this by these things. That means that will be 2 into 2 square. So dividing it by 2 into 2 square, then we will get what? 2 into 2 square and our 8 will be cancelled out. So we will get only 7 into 30 and we know that that is equal to 210 as the number of these types of element in A8. Okay. Now, if this element is a product of four disjoint transpositions, then there are then there are 8 factorial choices for 8 factorial choices of for the numbers in the cycle. However, now we must divide by 4 factorial into 2 to the power 4 by the same reasoning as above, the avoid overcounting. This is because there are 4 factorial ways to arrange the transpositions and 2 ways to arrange the numbers inside each transposition. Thus, we will get 8 factorial by 4 factorial into 2 to the power 4. So that is equals to our 8 into 7 into 6 into 5 by that will be 2 into 2 into 2 into 2. So this thing and this thing will cancelled out, and this will be cancelled out. So we will get only 105. And so total in this case, that means as the number of time in 8. So we conclude that 15 non-trivial homomorphisms 315 non-trivial homomorphisms from A7 to A8, and we are adding the trivial, then we will get total 316 homomorphisms from A7 to A8. So the correct answer of this question, that means the question is asking us that what is the number of homomorphisms from the symmetric group S7 to the alternating group A8, that will be equals to 316. Okay, so again I am telling that if you have any mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or you can drop and mail to our email ID which is written in the screen. So then you can enjoy all the services of Dr. Sourav Sir's classes. Okay. Thank you guys. Hope you understood. Thank you.